Oh, wrong display. Hang on. There we go. Okay.
Okay,
Right.
this is Steve. He's going to talk about programming with Lisp on the Pi.
Yep. Thanks. So it's a select bunch, isn't it? Yeah, so my name's Steve, and just by way of sort of an introduction, sort of how I come to be here, really. I was listening to the Raspberry Today podcast a few weeks back, which, if you don't listen to it, is really brilliant, actually. Gareth Davis of Fortronics was talking about the Pi to go, and what he said about the Pi was that it's the computer he's been waiting for 20 years, and I think that sort of matches my sort of thought about it, because I've really been interested in like the intersection between hardware and software for a long time. I started off as a hardware developer, and I've been forced to do software for the last 20 years or so. So the Pi coming along is really sort of the it means I can tinker with hardware again, which is really fun. So picture of some hardware. I quite like hardware. But the good thing about the Pi is because it's just Linux box. You can install all sorts of stuff on there. You could spend the rest of your life installing stuff from the distribution. And one of the things you could perhaps install is a Lisp. Actually, not with sudo apt-get at the moment, but that's. So looking, I was sort of wondering whether there are going to be any sort of 10-year-olds in the audience, and I suspect. Well, there aren't any 10 years on the audience. So has anybody actually used Lisp in? Yes. Okay. Okay. So a bit of a history lesson. So you had cooking in one of the early presentations. So we've got history here now. So this is a diagram that O'Reilly, the publishers, produced a few years back, which is sort of family tree of programming languages. So there's Lisp at the bottom, and if you look at the time scale there, okay, we're not quite 1960, so I think it's 1958 Lisp around, and it's the second oldest programming language in current use, the other one being Fortran at the top there.
Current use?
Just wait. But as you see, Python is 20 years in the future, basically, at the scale of this diagram. And I mean, there may not be time, but just, you can't see it possibly, but there are two other languages that you can see. One at the right at the top with the blue line is a language called Forth, and one at the sort of the burgundy line is one called Smalltalk there, and I might come back to that later on if there's a bit of time. So, why try Lisp, basically? A 50-year-old language, what possible use can it be in 2014? And the first thing is it's had a real, there's a lot of use of education with Lisp. In fact, many universities, MIT until about a year ago or so, used Lisp as the very first language they taught all their students, basically, humanities and sciences. And I like this idea of a bit of biodiversity. There's nothing wrong in learning something slightly out of the ordinary just to sort of inform your thoughts on programming. And it's also fun. So I don't know if you come across Sugru, which can be purchased just around the corner there. It's a sort of plasticine that sets when it reaches the air. And I think Lisp is a bit of a it's computing Sugru. So, and the reasons are, it's hand formable, okay, so Lisp can mould itself to lots of different applications in a very easy way. Sticks to almost anything, so Lisp is good at interacting with other systems and other languages. You can use it as a glue. And finally, no, that doesn't work actually, so it doesn't take you at room temperature. So this works with a bigger audience better, but two people put their hands up when I said, "Can anyone use Lisp?" Yeah, two and a half. So the first one, did anyone have one of these Roomba iRobot vacuum cleaners? Put their hands up, and they don't in the room, but it's possible. So that's programmed in Lisp. And if anyone's ever booked a flight online, almost certainly you've run a Lisp program, because one of the biggest suppliers of booking software or flight searching software, a company called ITA Software, who were bought by Google a couple of years ago, a lot of their stuff certainly has been written in Lisp in the past. So you might have used Lisp and not sort of realised it. And that, if you search for Roomba, I guess, let's get a drink, that's probably the most likely sort of variety of photo you see on the internet. If you search for an iRobot Roomba, it'll be an iRobot Roomba with a kitten on it, possibly a kitten dressed in a dinosaur outfit, riding on it, because there's a bit of an internet meme about kittens on robot vacuum cleaners.
That's the program, right?
Sorry?
That's the program.
So, but I mean, people say, you know, Lisp is dead, 50-year-old language is dead, but I like this quote. So, Lisp is, as you know, there's a family of languages. It's not one language, and there are two big chunks of languages. One is Scheme, or this is sort of modern Lisps. One is a set of language called Scheme, and GNU chose a variety of Scheme for their scripting language. So things like lots of graphics programs use it as a scripting language. The second sort of bunch are called Common Lisp. There was a standardization effort in the 1990s, and there's a whole set of languages that sort of conform to that standard. And that's really sort of, I guess, industrial Lisp, like the booking software would have been written in Common Lisp probably. And there are some really good implementations. That one called Steel Bank Common Lisp is really good. And the Armed Bear one, I always wanted to use that just because its name. That's a Common Lisp that runs on top of Java Virtual Machine. But at the bottom, yeah, exactly. Well, yes, that's why I haven't used it. The bottom two are sort of more modern Lisps. One called Racket, which I'll just give a quick demo of today, and another language called Clojure, which again, runs on top of the Java Virtual Machine. And I guess it's used by people who can't bear to write another line of Java, but actually, you know, want all the infrastructure that goes underneath it. So the language. So the language that I'll try and do a demo of, you know, demo gods permitting, is this language called Racket, which has been around for, I don't know, about 10 years. It's used a lot in teaching and in sort of language research as well. And that's their sort of landing page, which sort of tells you they think it's a programmable programming language. And it's a sort of evolution of Scheme, really. It comes with an IDE, which, although it looks a bit sparse, is actually quite nice. And the only snag with this IDE, which is why I won't demo it today, is it's a bit like Mathematica. You can run it on the Pi, and you can do useful stuff with it, but it's not so snappy that you might not get quite frustrated with it. So, as you spotted earlier on, I'm going to try and demo a bit with another environment. And if you'll forgive me, provided the Bluetooth keyboard works from here, I'll sit here and do it, because then I can see what I'm typing. Okay, so this is Racket running on a Raspberry Pi. Yeah, that works. Can I type? Let's see. So this is the Emacs Editor, which, you know, I guess it's sort of the same era as Lisp, really, slightly newer than Lisp. But you can actually run a development environment with Emacs on the Pi, and it's reasonably snappy. So what you see here, there's two windows. The bottom window has got the interaction window, so you can type stuff into that, and Lisp will come back with an answer, hopefully. And then the top window is a text editor. So I guess it's a bit like, you know, lots of IDEs, like the Python IDEs. And what you can, so we're in the bottom screen at the moment, and we can just type something in. So again, you'll be familiar with the fact that Lisp does things in slightly different ways, that brackets tend to group expressions, and the operator comes first. So +1 and 3, 4, few. And then defining a function, you can say define, let's say 2 more than, and then a number, and then we can say plus 2n. So in theory, we've defined a function to add 2 to anything, and then we can say 2 more than 2, and yeah, we'll get back. Well, now what's slightly different about Racket, and their own IDE does this a lot better, but it's actually this particular plugin for Emacs doesn't do a bad job. What you might not have seen is, I can type, and yes. Now the reason that didn't work is that I haven't done this. Am I doing that?
You're not, I mean, Emacs comes with its own list, doesn't it?
It's programmed. I just need a bit of a crib sheet. Hang on one second. It's actually all the extensions are programmed in its own variety of Lisp, and yes, I have done the right thing.
Racket is not.
No, Racket. So what's happening here is you've got the Emacs Editor, and you've got it talks to Racket through. There's a plugin called Geyser, which provides the communication between the two. So I think I've done that correctly. So if I go. Yeah. Okay, so back to where we can type stuff in, and hopefully this time that shall work. Now, what the reason it didn't work in previously was that I hadn't actually imported a graphics library, which is the thing on the touch screen you see require to HTTP image. So, in theory, we get a red circle. And the nice thing about that is that it's particularly for teaching is that it's got the feedback of graphics. And that sort of gave me a sort of thought in many ways. So what if we do something like this? So the subject of this is traffic lights, I guess. So we can define a simple traffic light, which has got those 3 circles, one above the other. So there's a graphics primitive that says above, which places the things above each other. So if I execute that, did I have? No, we haven't that. Why did that not appear? It's the demo goals, isn't it? Let's try that again. Oh, yeah, I know why. Yeah, somebody has probably spotted this already. I've just defined the function there. I haven't actually called it. Yeah. So if I say simple traffic and execute it, hooray, we've got a traffic light. And the other thing we can do then is perhaps use some of the. I mean, there's loads of graphic primitives there. So here, there's something called a star polygon, which looks a bit like that. So what about constructing a traffic light from that stuff? So if we go there, and we've got a function there that says it defines a function called light, which has got a particular color and a flag to say is it lit or not. And what it does is if it's lit, it shows the star polygon. If it's not lit, it shows the little circle. So if we have all right, so that's a non-lit light. And if I change it to being lit, and do the same thing, you've got a lit traffic light. Okay, so now then. So if we draw a fancy traffic light with using those graphics, we've done exactly the same as before, but instead of drawing a circle, we draw the light. So with Lisp, you're basically defining small functions and iteratively building up the program you want to exist. So if we do a fancy traffic light, so red is false, yellow is false, and green is true. And yep, there we go. And so now if we want to model the states that a traffic light can have, so we've got 4 states, corresponding to the 4 possible colours we have on the traffic light, or states of colours, and so we're defining a traffic light here, which is going to draw the traffic light corresponding to a particular state. So if it's in state 1, it'll draw red. If it's in state 2, it'll draw red and yellow. So if we go down here and do that, sure enough, we get a traffic light in state 2. And go down a bit further. So if we want to look at the sequence of traffic lights, here again we're using one of the graphics primitives, which is beside, which will draw some images beside each other. And if we do that, we've defined it again instead of running it, and then if we do that, it should draw the 4 sequences of traffic light. So I mean, in Lisp you're very often building things up in that very iterative way, and that's what I quite like about programming in Lisp, in that you can build a little function, call it and see what happens, and it either works or it doesn't. And that makes it easy for testing as well, because you're splitting things down quite. So okay, now this is where if I plugged in my Pi stop traffic light into the Pi correctly, this may or may not work. So the Pi stop, I don't know if you've seen them, they're available just around the corner there, 2 for £5, not on commission, and it's just a little traffic light with 3 LEDs, which is really good for sort of feedback. So let's see what happens if I do that. Oh yeah, that's good. So that's I'm sorry, the angle of view may not be optimal for everybody here, but okay, we just tested that it works. So well, there's do you know wiring Pi? So I've written a little function library that plugs Racket into wiring Pi, basically. So Pi stop traffic, what's that going to do? Let's have a look. So that in principle, I guess that should light up the yellow light or amber light. Yep. Well, possibly yes. Okay. And then we can, now, I don't know if you noticed in that function above here, fancy traffic. Yeah. Okay, so, traffic light. Instead of actually specifying exactly how we produce whatever the output we want is, it actually has a function. You pass it a function that says, how am I going to display this traffic light? So in the first example, we displayed it as graphics on the screen, but the other nice thing is we can just change that drawing function and in principle get it to do the same thing on the... Oh, it's done the same thing, hasn't it? That's not very good. Okay, yeah. So yeah, we've got fancy traffic there, which is that, and if we do that. Does that look right? That doesn't look right to you. Does that look right to you? We should have. Oh yeah, it is right. We should have. So if we do that, we should have a red light on. Yep, we do. Yeah. And then the last thing we can do is define a sequence of traffic lights, and this uses some additional bits and pieces that become second nature in Lisp. And I won't go into that just now because I've got some extra slides to show. But effectively what it's doing is it's taking a set of state numbers. So we're going to start off in state 1, 2, 3, 4, 1, 2, 3, 4, etc. and draw the traffic light in principle. And we've defined it, as I keep on doing rather than running it. Yep, The wonders of technology. So, I mean, that's it for showing that little bit of a demo. And it's pretty snappy, you know, it's running stuff on the Pi using Emacs and this plugin library. And it's installing Emacs is obviously just sudo apt-get, so that's easy to do. And the Geezer libraries are also, I think you can do that with apt-get, although I just downloaded it and dropped the source file in there because to get the latest version. So that's quite a usable environment for running Racket, and you can run other Lisps using the similar interface. So back to the slides. Okay. And play. And swap the display over. This software always ends up with the presenter display on the big screen and the presenting screen there. I do like that quote as well. That this is a quote by Alan Kay, who you probably know is the guy who invented the personal computer and all the stuff that goes along with it. So his views I quite respect. And what's not to like about the language which spawned the coolest ever looking computer, which is I can't remember which particular version it was, but this is a thing called a connection machine, which had, I mean, I think it depended on the depth of your pockets, but in the 1990s, you could, in principle, you could buy one with 65,000 processors in it. Probably you could, your pockets weren't deep enough for that, but
Where is rocking off?
yeah. So, but that was, they did a lot of software in Lisp, in a parallel version of Lisp on that.
One of them located somewhere, and it's waiting to be. Well, the problem was it's full of government data.
Right. Yes.
So they're not allowed to let anyone have it.
Sure,
so
yeah.
The government data is no longer confidential because nobody knows how to decommission it.
Okay.
It's the only people that programmed it are dead or whatever.
Yeah.
So it's sitting in the bottom of this cellar, full of this government data, and no one's allowed to touch it. It's locked there.
Yeah.
And they're waiting for it to be it's not in this country, but as soon as it gets decommissioned, it's going to the Computer Museum in Milton Keynes.
Oh, brilliant! Yeah, okay. Yeah, I guess a lot of those were bought by companies with three-letter name, acronyms basically, like NSA. And anyway, that's there's also one on Jurassic Park 2, but not that particular model. I think. I think it's the one that let the dinosaurs out by mistake. So.
You've let them out, and no one knows why. Or how.
Someone put semicolons in
Okay, so should you want to try Lisp after this, there's some really good resources. I mean, there's two main dialects, Scheme and Common Lisp, and the book for Simply Scheme.
Racket. Was that Scheme?
Racket was a scheme. It used to be called PLT Scheme, and they renamed it Racket because it's sort of extended Scheme, and they felt a bit embarrassed about still calling it Scheme.
Is that the one you'd recommend? Or?
It's the one I've got a couple of recommendations here. So basically, Racket is it's quite big in education in the US. It's not really caught on much over here, and there's some student programs that use it. But it's got a really nice, the IDE, although it looked a bit sort of bare and minimal, it's actually quite nice. And there's a really good course, the course previously called Coursera. They do these online multi-user course things. They did a course last year called, what was it called now? It was an introductory computing course, but it used Racket as its teaching language, and it was very, very good actually. And if it comes around again, it's worth having a look at because it's an excellent course. This book here, Simply Scheme, it's a bit dry because it's purely textual, but it's intended as a sort of starting point to get on board with Scheme, and as an introduction to a book called Structure and Interpretation of Computer Programs, which is, I mean, people argue that it's actually the best computer science textbook ever written. However, they start off by saying computer science is actually not a science, and it's not much about computers. So it's a bit controversial, I guess, in the current sort of things. The other thing which is really good, I guess this would go down really well with kids. There's a book called Land of Lisp, which uses Common Lisp, and you can install Common Lisp from a package on the Pi. So it's, you know, it's not difficult to install.
Is Common Lisp backwardly compatible with Scheme? Sorry, Scheme backwardly.
No, they sort of diverged basically, and there's a lot of common stuff, but effectively they're the two current flavours of Lisp basically. Scheme is the sort of IKEA version of Lisp, and Common Lisp is, I'm not quite sure how the metaphor works, but it's got everything and the kitchen sink built in, sort of thing. Is Common Lisp, and Common Lisp is the one you'll find used industrially largely. But this is a brilliant book, and it is slightly eccentric. I recommend searching for the Land of Lisp YouTube music video because it is very good. The guy who did this, he obviously Konrad Barsky MD, so obviously started off as a you know, in medicine, but he's quite good at drawing cartoons, and he's got a really good take on programming. And he also contributed some logos that have sort of been adopted as sort of mascots of Lisp, really. There's a complementary book to this. This came first, and I think it's the better of the two books. There's actually a book called Realm of Racket, which is his. He helped other people write a book about Racket as well. I think this is the better book because it's sort of more focused on his work. Yeah, so that's it really. I've got some references there if anyone wants to, like for example, you know, quickest way to install Lisps on the or to install Racket anyway on the Pi.
Can I ask you what would be the benefit of using Lisp over, say, I mean, where does it fit in performance-wise? I mean, obviously C is one of the faster languages, Python's sort of...
It fits between the two. I mean, you know, the historical, you know, when you said Lisp to people historically, they'd think, oh, something incredibly slow and useless. Right. In the meantime, you know, Lisps have got all the modern compiler technology that, say, Java has got. It's got just-in-time compilers and stuff like that. So Racket is a compiled language. So, particularly, I mean,
can you use Lisp interpreted or compiled, or is it
some versions make a distinction. I mean, Racket doesn't, because you just type stuff in and it comes back, and the fact that it's compiled it in the background, you need never know that basically.
So
Yeah, yeah,
right, okay.
yeah.
But some bits of this won't work if it's compiled. Or does it do on the go?
It will do stuff. Yeah, the compilers these days can let it do some of the stuff that you might think you couldn't. Basically, yeah.
But you'd have to do some. I mean, Lisp can create Lisp and run itself, can't it?
Yeah, but you can actually do that. I mean, it can you know, compile it on the fly and run the compiled code basically. Yeah.
But you've got to be compiling on the fly. You know, sort of as the program's executed.
Yeah, it'll do that. Yeah. So yeah, that's it. So it works nicely on the Pi.
So performance-wise, it's...
Oh, sorry, it's between the two. Yeah. I mean, particularly, the one reason I was interested in it. I mean, I actually use Racket for sort of some day-to-day work, which isn't at all in sort of interfacing. But I quite like Racket, and it's a bit faster at doing. If you want to do sort of actual bit twiddling without going to C or something, it'll do it faster than Python.
I mean, that's what was interesting, because obviously the theme of next CamJam is robotics.
Yeah.
And we were talking about in the last lecture, I don't know if you were in here, where we were talking about different controllers and really pushing the boundaries, trying to do
Yeah.
It is possible, but so it'd be interesting.
It'd be interesting to see.
It's in the middle or something.
Yeah, it'd be interesting to see what that PID control looked like in. I mean, how fast it performed in Racket.
Yeah. Is Racket one of the quicker ones, or are they all muchness?
I think you'll find like the common Lisps have got the edge in speed because they've had the time to put the effort in to do that. But Racket,
yeah, I mean, this is what I was trying to get at when we were talking about the different versions of this.
Yep.
Common or I mean,
yep.
Let's say you had a group of people that were trying to do something in robotics, and they didn't need to have any connection with legacy systems, so it's all fresh. They're all starting from scratch. Are you saying that Racket would be the one to go for?
Definitely, yeah. Definitely.
Is that because of the ease of programming it?
Ease of use, and it's got really good environments. I mean, it's got environments for Windows and Mac OS and Linux,
Right.
which
so it's best supported.
Yes, and I think it's got a lot of the best introductory material as well.
Right.
In those links there, there's a link to actually a way of installing Racket on the Pi, which I don't recommend now. But incidentally, it's got a link to some videos, and there's a really good program in the US called Bootstrap, where they teach kids to program games using Racket, and it's very, very accessible, basically. Yeah. And there's practically no syntax, so you don't have to teach. You know,
Yeah,
if you
when I did Lisp, I quite enjoyed it because there was
going back to that very first history slide, those three languages, Forth and Smalltalk and Lisp, those are the three languages that I've ever used where you actually feel you're in a bit of sort of communication with the computer, and you can sort of think up something and actually get the computer to do it, sort of with the less hassle, basically.
Any other questions?
Yeah. Have you, sorry, let's rephrase what I was going to say. Would you consider marketing these little traffic lights things to model railway people? Because they would die for those.
You just have to walk round the corner, and the man from Fortronics will be happy to sell you as many as you like.
It's not me, I'm saying that. I know a lot of model railway enthusiasts. Hundreds of engineers. Love those things.
Yeah. No, I think they're great. Because the other nice thing is, it just plugs directly. If I can remove the blue tack, plugs directly onto the GPIO port. So, and you can actually, it's designed so you can actually plug 4 of them onto the GPIO ports. So yeah, it's really nice. Really nice with demos. Yeah. But yeah, the man around the corner will sell you them, and I don't get any cut, sadly.